Okay, I chose to do this problem from 1 to 9 instead of 0 to 8, so that we would actually have a rectangle when we use left-hand endpoints for this first rectangle, and also we'd actually have a trapezoid when we use the trapezoidal rule. So I'm going to go through the lower or left-hand and right-hand sums pretty quickly, but the number of rectangles or subintervals was supposed to be 4. That's right here. The left-hand endpoint is 1. The right-hand endpoint is 9. So each delta x is 2 in length. That's what the bases of these rectangles are. So to find the area, we just need to find, using left-hand endpoints, we'd start at 1 and go 2 to the right to get to 4 rectangles. So I call this rectangle 0, 1, 2, and 3. And so here is how we calculate the areas of those 3 rectangles. This is the height, this is the length, or length and width. And if you add those all together, you get 168. If I go to board 2 and quickly talk about right-hand endpoints, the right-hand endpoint starts at 3. That helps us define rectangle 0, 1, 2, and 3. That gives us an overestimate for the true area. So the endpoints that we use are 3, 5, 7, 9. Here's the calculation, and we get 328. If we move to the trapezoidal rule, here's the average of those 2 areas that we just found. So hopefully we're getting 248 as our answer to using the trapezoidal rule. Now the trapezoidal rule, we still divide this into 4 equal subintervals, and we start with x sub 0 at 1. X sub 1 is 3, 5, 7, 9. And if you connect those points, you've got a trapezoid, because these 2 vertical segments are parallel. And the formula for the area of a trapezoid, one way to write it is 1/2 the height, which in this case is 2, times the sum of the 2 bases. So for trapezoid 0, 1/2 delta x, that's the height, times the sum of the 2 bases. Well, the 2 bases are f of x sub 0 and f of x sub 1. And if we follow that pattern for the other 3 trapezoids, and then take a glance at what happens when we add these all together, all of these areas contain 2 factors 1/2 delta x, so I can factor that out and just add these f of x's. And what you'll notice is that the left-hand f of x sub 0 and the right-hand f of x sub 4 only appear once, but all the other ones appear twice. F of x sub 1, f of x sub 1, f of x sub 2, f of x sub 2, and so on. And that's where the general formula comes for the trapezoidal rule. And if we substitute in the numbers, I'll let you view that, we do get an area of 248. You could prove this in general without using a specific function or a specific number of subintervals. But that's another story. There you go. Hope that helped. If you have any questions, post a comment.